Forces and energy. Question 1. Let's read the question. A train on a straight level track is pulled at a constant speed of 23 meters per second by an engine with an output power of 700 kilowatts. How much energy is transferred from the train to the surroundings in 300 seconds? In order to answer this question, let's start with something we know. Speed is 23 meters per second and power is 700 kilowatts. Power is equal to energy transferred divided by time taken. Let's substitute the power, which is 700 kilowatts. Here, kilo means thousand, so 700,000 is equal to energy transferred, which we need to find out, divided by the time taken, which is 300 seconds. So energy transferred is 700,000 multiplied by 300. So when we calculate this on the calculator, it is 210 million joules of energy transferred. 210 million joules can be simplified to 210 megajoules, mega standing for million. Moving on to the next question, it is how far does the train travel in 300 seconds? So in this question we need to find out distance, but we are given time, which is 300 seconds, and speed, which is 23 meters per second, the constant speed. Use the formula speed is equal to distance divided by time. We need to find distance, so that is speed multiplied by time. We can substitute speed as 23 and time as 300 to find distance, which will be 6,900 meters. So let's move on to the third question. Show that the resistive force on the engine is approximately equal to 30,000 newtons. To answer this question, there's some interesting information we need, which is that the train is traveling at a constant speed of 23 meters per second. When something is traveling at a constant speed, this means that the forward force is balanced by the backward force, or forward force is equal to backward force. So there is no resultant force, which is why it is traveling at a constant speed. In our case, the forward force we're talking about is a driving force of the train, and the backwards force is a resistive force that is being asked about in the question. So the value we don't know and we're trying to find is the driving force. But we do know the energy transferred, which is 210 million joules, megajoules. After that, distance is 6,900 meters. We need these pieces of information because there is another formula, which is work done is equal to force multiplied by distance. But why are we using work done? Work done is the same as energy transferred. So we could also just say energy transferred is equal to force multiplied by distance. We can rearrange the formula to find force, which will be energy transferred divided by distance. So substitute the value for energy transferred, which is 210 million, divided by distance, which is 6,900. When we calculate this is 30,435 newtons, and we want to round it to two significant figures because the values we used for energy transferred and distance are also to two significant figures. So our final answer is 30,000 newtons. Question 4. Explain why the driving force of the engine is equal and opposite to the resistive force on the train. It's the same idea from question 3, which is that if the train is traveling at a constant speed, then its forward force, driving force, is equal to its backwards force, which is the resistive force. There is no resultant force. In another case, if there was a resultant force, we would have seen instead that the train would accelerate or decelerate. Question B. The train then moves on an inclined section of the railway line. So previously, the train was just moving across a flat section of the railway track, but now it is moving on an inclined section, which means that it's slightly sloping, where the track rises by 1 meter for every kilometer of track. Explain why the output power of the engine needs to be increased to maintain the same speed of 23 meters per second. As the train moves uphill, it gains gravitational potential energy. And if the speed is same, which is 23 meters per second, and resistive forces are also the same, then the same amount of energy is transferred to the surroundings. For energy to be transferred to both the surroundings and to the train as GPE, the output power should thus increase. Thank you for watching. If you enjoyed this video, make sure to subscribe and give a like. I'll see you in the next one.